Okay, everybody. So today I'm going to teach you about balancing chemical equations, okay? So what I want you to do is you were all handed a handout. So please follow along while I'm covering some of this information. That way you'll know what to do when it comes time for you guys to try it on your own, okay? So when you're looking at chemical equations, you'll see formulas for molecules that look a certain way. Okay, so let's take a simple molecule. All right, let's say you have H2O. All right, so H2O, that is obviously the formula for water. Okay, now you'll notice this 2 right here. Okay, that 2 is a subscript. Okay, so what a subscript is, what a subscript is basically denoting how many atoms of the atomic symbol before it are present. Okay, so in this example, there are 2 H's. Okay, H is for hydrogen. Now, there could also be no subscript present. Okay, when there's no subscript present, then that is assumed to be a 1. Okay, so for simplicity's sake, scientists instead put nothing. They just leave it blank. So in this molecule right here, there are 2 hydrogen atoms. And 1 oxygen atom. Pretty straightforward, right? Now, another thing that you'll see is you might see a number that comes before the entire molecule. Let's say this is a 5. Okay? This number right here, this is called a coefficient. Okay? In this example, or whenever you see this, the coefficient is telling you that whatever this molecule is, this is how many of them there are. So in this case, in this example, there are 5 water molecules. Okay, so in order to determine how many of each atom there is, you have to multiply the coefficient times the subscript. So right here, there are now 10 hydrogens, 5 times 2, and there are 5 oxygens, 5 times 1. Okay, so the point of balancing chemical equations is to determine what these coefficients are. Now, as you'll see from the board, I have some examples. Okay, so why don't we look at one example balancing problem together? Okay. Okay. You know what? I better erase this too. Okay. All that information is on the handout, by the way, so it shouldn't be a big loss if I erase that. So let's take an easy one. Why don't we do number 1? Okay, we'll just start with problem number 1. Okay, it's H2 plus O2, and that goes to H2O. Now you might remember this because this is the opposite of the electrolysis problem. Remember that in the electrolysis experiment, we were taking water and we were splitting it into these 2, okay? However, in this problem, we're taking these 2 and we're combining them to make water molecules, okay? So what we're gonna do is we're gonna make a little chart right here, okay? We're gonna put an R for the reactant side. Remember, left is reactant. We're going to put a P for product side, right as product. Okay, and we're just going to list each atom that we have. Okay, so we have hydrogens and we have oxygens. Okay, now on the reactant side, we have 2 hydrogens. There's currently a coefficient of 1, subscript is 2. There are 2 hydrogens. We also have 2 oxygens. Now on the right side, we have 2 hydrogens, still a coefficient of 1. We have 1 oxygen. Okay? Now, in order for this to be balanced, both the reactant side and the product side for each atom need to be equal. Okay? So, obviously we need to add more to the product side, right? We can't take away, we can only add. So, here's the thing about balancing. It would be easiest if you could do something like that, right? But the problem is you're not allowed to do that because what you've done here is you've made this into a completely different molecule, okay? So we can't do that. So all we can do is change the coefficient, okay? We're allowed to do that because each one of these represents 1 atom, okay? And remember that we have many atoms at once, okay? So if you need to switch this from one water molecule to 2, it's not a problem, okay? And that's exactly what we're gonna do. We're gonna make this into 2 water molecules, okay? So now we have 2 oxygens. There's only 1 per molecule and there's 2 of them. It becomes 2. You okay? But we now have 2 times 2, that's 4 hydrogens, okay? So we've got a problem here. So we need to add hydrogens to the reactant side, right? We now have more on the product than the reactant. So we need 4 and we've got 2. So we need to make this into a 2 right here, okay? So now we have 4 and 4, that's good. 2 and 2, that's good. Everyone see how I did that? A lot of very quiet faces out there. Let's try doing another one. Okay. Let's do one that's maybe a little tougher. Okay, that one's pretty easy. Okay, let's do number 2, I guess. H3PO4 plus KOH becomes K3PO4 plus H2O. Okay, so we're going to make our little chart right here. Reactants, products. Okay, so let's start just naming off all the different atoms. Okay, we've got hydrogen, we've got phosphorus, we've got oxygen, we've got potassium. Okay, so let's take them one at a time. Now, one thing that we might want to notice here is that each one of these has an oxygen. Okay, so when that happens, it might be best to leave it towards the end. Okay, calm down. Take it easy. You should just be following along with the paper. Okay, so let's leave oxygen for the end. Let's start with, you know what, let's just write down what we've got first. Okay, so we've got 3 hydrogens. 3 plus 1, that's 4. Okay, we've got 1 potassium, that's 1. We have 5 oxygens. And I'm sorry, I said potassium, that's phosphorus. We have 1 right here. Okay, On this side, 3 potassiums, 1 phosphorus, 5 oxygens, 2 hydrogens. Okay, so interesting. Okay, so let's start maybe by balancing the potassiums first. Okay, so you got 3 on the right, 1 on the left. Let's change this to a 3 right here. Okay, I'll make that 3. We also changed the number of oxygens. We have 4 plus 3, that's 7. We also changed the number of hydrogens. 3 plus 3, that's 6. 6 hydrogens. Okay. So let's take a look at the hydrogens. Okay, we have 6 on the left side. On the right side, we've got 2. Okay, so you have 2 right here. 2 times 3, that'll be 6. Let's change that to a 3. Okay. That'll be 6 now, right? 3 times 2, that's 6. 3 there, 3 there, that's also 6. So we're just left with oxygen, right? But we changed this now. There's 3 oxygens there, there's 4 there. That makes that 7 now. And we're now balanced. Okay, so how about we do one that's even harder? Let's take a look at number 14, okay? Because this is a good opportunity to show you something new. Okay, number 14. My eyes can read that, right? That is AlOH3 plus H2CO3 goes to Al2CO3 2 plus H2O. Let me just double check that. I'm saying that right. So it looks good to me. Okay, so let's start by making our chart. Okay. So we've got aluminum, it's right there. We're gonna have oxygen. We've got hydrogen. We've got carbon. Okay. Reactant side, product side. Okay, let's start totaling them up. So 1 aluminum there, oxygen. Oh, okay. So here's the thing about these parentheses right here. So if you remember PEMDAS, okay, and most specifically distribution, then you'll remember that any number that is multiplied times something in the parentheses must be distributed to each term. Okay, so in this, there are a total of 3 oxygens, oxygen, and 3 hydrogens. Okay, so if we have 3 oxygens here and 3 oxygens there, that's 6. There's 3 hydrogens, 2 hydrogens, that's 5. There's 1 carbon. Let's look at the right side. We got 2 aluminums there. Okay, so let's look at carbons. There's a carbon right here. Carbon times 2, that's 2 carbons. Okay. There's 3 oxygens on the inside, 2 on the outside, 3 times 2, that's 6, plus 1, that's 7. Okay? Hydrogen, we've got 2. Yikes. Okay, well, no use crying about it. Let's start out by balancing aluminum. Okay? A lot of times if you start leaving like these two closer to the end, it's a little bit easier to do. Okay? So we multiplied aluminum times 2. We also have to multiply these times 2. So 3 oxygens times 2, that's now 6 oxygens, plus 3, that makes 9. 3 hydrogens times 2, that's 6, plus 2, that's 8. X. Okay. Let's try balancing carbon next. This is going to be interesting. Okay. So let's make carbon a 2. So in order to do that, you got to put a 2 there. But that changes this whole dynamic right here. Okay. So you put a 2 there. Carbon's now 2. But you've also just added 2 more hydrogens. Okay. So this is now 10. Right. Let's double check real quick. You have 3 there. 3 times 2, that's 6. Plus 4, that's 10. Okay, let's look at oxygens. There's 6 there. There's 6 there. That should be 12. Okay. But on the plus side, knock those out. Now, the real challenge here is that we want to balance these two without changing these two if we can avoid it. Whether or not we can do that, that's going to be an interesting challenge. Okay, so right here, we have 6 oxygens. Right? So if we were to take 6 out of 12, let's see. This one's a little bit harder. Okay, so we have 6 oxygens tied up right here, right? So that means that of these 7, 6 of them belong right here. And there's only 1 over there. So let's try just balancing the hydrogens maybe, okay? Let's try making this a 5. Okay? So if we make that a 5, this becomes 10. Okay? Now, this means that there's 5 oxygens here. We have 6 there. That makes that 11 oxygens. Yikes. That sucks. So obviously now we've run into a problem because we don't have a balanced equation. 11, 6, 6, that's 12. Okay, yeah, so oxygens aren't balanced. So what do? Well, we have to come up with some other solution. So what if we're going to have to make some changes here. Okay. So we're 1 oxygen short. So we need to be able to get 1 more out of this somehow. What if I made that a 3. And then that would be a 6. No, that's tough. Okay. I didn't try this one ahead of time. I'm hoping that this one's not too hard, guys. Okay. So let's try doing this instead. Let's make that. Let's try making this one a 4 and this one a 2. Okay. So we're going to backtrack a little bit here. Okay. So if we did that, we would have 4 aluminums. We would now have 12 oxygens plus 3, that's 15. Okay. Hydrogens, we also have 12 plus 2, that's 14. And carbon, we would have 1 currently. Okay. Here we've now got 4 aluminums. We've got 2 carbons times 2, that's 4 carbons. We have, there's no hydrogens there. We currently have 2 hydrogens here. And we also have 6 times 2, that's 12 oxygens there. Okay, so just a little bit of bookkeeping, so that way we know where we're at. So let's balance carbon. So if we put a 4 here, it'll become a 4. 4 times 2, that's 8 hydrogens. So we have 8 there plus 12 there. This becomes 20. We also have 12 there and 12 there. This becomes 24. That's 12, so this is actually 13, okay. Now, really, in this situation, what we're looking for is when you take out these 12 oxygens, can you get a situation where you have you need twice as many hydrogens as you need oxygen? So, ideally, 24 minus 12, that's 12 oxygens. You also need 20 hydrogens. So that would be a 10. So we put a 10 there. So you put a 10 there. 10 times 2, that's 20. 12 plus 10, that's 22. Oh, there it is. So that's why this ended up so difficult. This is actually supposed to be a 3 there. Okay. That's why I was 1 oxygen short, guys. I should have checked that closer. Sorry. So let's fix this real quick. Something tells me that it's going to go a lot quicker now. Okay. All right. This is why you read the problems carefully. Okay. All right, so backtracking. We have 1 aluminum. We have 3 oxygens there, 3 oxygens there. That's 6. 3 hydrogens there, 2 there. That's 5. We have 1 carbon. Okay, 2 aluminums, 3 carbons. We have 2 hydrogens. Oops. 3 carbons. We have 3 times 3, that'll be 9, plus 1, that's 10. Okay, so let's balance aluminum first. That'll be a 2. Change that to a 2. We'll also be adding oxygen. So we had 3 there times 2, that's 6, plus 3, that's now 9. Hydrogen, 3 times 2, that's 6, plus 2, that's 8. Okay, let's balance carbon. We need that to be a 3. So this has got to be a 3. 3 carbons there. Okay, we've also changed the hydrogens. 3 times 2, that's 6. 3 times 2, that's 12. 3 times 3, that's 9. 9 plus 6, that's 15. So we need 15 oxygens. Okay, and right here, 3 times 3, that's 9 oxygens. So that means that we need to get 6 oxygens from this guy right here. Okay, we don't want to touch this one because that'll mess up these two. Okay, and we need 12 from this one. Yeah, so this one. Okay, so we've got that 2-to-1 ratio now. So if this becomes a 6, 6 times 2, that's 12. 6 times 1, that's 6. 6, 3 times 3, that's 9. 9 plus 6, that's 15. Whew. Thought Mr. Andrew was losing it there for a minute, okay? All right, so why don't you guys try to do number 3, okay?